Okay, hello everyone, it's Salar and we are in part 51 of our tutorial to writing a real-time operating system. In previous part, I implemented some other threads system calls, some system calls that's related to thread, okay? Getter system calls. I implemented getter system calls for thread, and I added idle thread to the RTOS. Okay, but in this part, I want to start talking about wait in RTOS or delay in RTOS. How can we make a delay in running up a thread? Stop running up a thread for a specified time to make a delay. Okay, to make a delay, RTOS does this works. To make a delay, first RTOS must delete thread from ready list, because when you want to make a delay, the RTOS mustn't run that thread for a specified time, for a delay time, or for example for 2 seconds. For 2 seconds, RTOS must delete thread from ready list and doesn't run the thread. Okay, after deleting from ready list, the RTOS must insert thread to the wait list. Waitlist is another data structure in the RTOS. I said all of data structure called list. Insert thread to the waitlist for a specified time. Desired delay. Okay? And until finishing this time, until elapsing the delay, RTOS mustn't run the thread. Mustn't run this thread. Okay? Until finishing the delay. After finishing the delay, elapsing specified time, RTOS must return thread to the ready list. Another time to ready list, delete from waitlist, and another time insert to ready list. After the specified time has elapsed, after finishing the delay. In this way, you can make a delay. RTOS can make a delay. Stop running up a thread for a specified time. But let's talk about structural waitlists. Okay, structural waitlist is here. Okay, and you can see the structural waitlist. Like a structural ready list, you have an array of pointers. This is array of pointers. In ready list, each element of array point to a circular queue. But in waitlist, each element point to a simple queue. Okay? And for example, number of queues is 8, 0 to 7. And when RTOS wants to insert thread to waitlist, RTOS must insert thread to one of these queues, Q0 to Q8. Why do we need to have 8 queues, for example, at this time 8 queues, more than one queue? Because by each systematic interrupt, systematic exception, RTOS must check waitlist. Okay, and when you have more queues, for example at this time 8 queues, check time on waitlist decreases. Okay, you can decrease the wait list check time, because checking this wait list takes a time, and by using of this way you can decrease the average time. Okay, the average time. Okay, but as I said, when RTOS wants to insert a thread to waitlist, RTOS must insert thread to one of these queues or one of these lists. Okay, but which list? To answering to this question, which list, let's see an example. Assume RTOS want to insert a thread to the waitlist. This means you have a delay. Assume at this tick time, current time is 0. You want to make a delay, and the time of this delay is 500 milliseconds or 500 ticks, because each tick equal to 1 millisecond. 500 millisecond is 500 tick, and your desired delay is 500. At this time 0, you want to put the thread to the ready list for 500 milliseconds, so thread must return to ready list at this time. Current time, current tick plus desired delay. By using a return tick, you can select one of these lists, one of these queues, by using of this formula. Return tick modulated by number of waitlist. For example, here 500 modulated by 8, number of waitlist equal to 4. Now RTOS must insert thread in this queue. Okay, and after finishing the delay, elapsing the time, specified time, another time must delete thread from this queue and insert it to ready list according to the priority of the thread. But for returning a thread to the ready list, after finishing the delay, RTOS must return a thread to the ready list. But RTOS doesn't know when is this time. Okay, RTOS doesn't know when a thread delay elapsed, and RTOS doesn't know. Let's say that in this way, RTOS doesn't know when delay finishes for a thread. Okay, because of that, by each systematic exception, each 1 millisecond there is a systematic interrupt, RTOS must check waitlist, check this list, all of these queues, one of these queues, it's better to say one of these queues. Okay, to see is there any thread with run out delay. Okay, with a finished delay. So each 1 millisecond, RTOS must check the waitlist to find those finished delay. But assume for thread 1 the delay is over. I said the return tick is 500, and now current tick is 500. Logically, you can find the thread in this list by modulating current tick, that is return tick of the thread. Another time by number of list is for logical. You can't find the thread in this list, in list number 4. Okay, and RTOS must delete the thread from wait list number 4 and insert it to ready list. So RTOS must check list number 4. But there may be some other threads in this list. For example, a thread with 900 return tick, because 900 modulated by 8 is for like 500. But RTOS must return the thread with this return tick, because at this time current tick is 500. Okay, so to return thread to the ready list, RTOS must delete thread from wait list and return it to ready list. In this way, you can implement a delay. Okay, RTOS does these works to make a delay for a thread. Okay, this was the structure of wait list and delay in the RTOS, and in next part I will implement a system call, and I will implement thread wait. By using a thread wait, you can make a delay. So in next part I will implement thread wait. Very good. Thank you very much to see me, and see you soon in the next part. Thank you very much.